Okay, this video is dealing with what is an inelastic collision. What is an inelastic collision? An inelastic collision is basically when two objects collide and they stick together, and they move off together. So they may move off. They will move off with a slower speed if they combine, and they'll stick. So it's kind of like in football, like when a player tackles another player. They'll move off. Okay, so basically what happens here is that this object, let's just say we have a before and after picture. Okay, we have a before and after. So here's the before and here's the after. Okay, so let's just say that these two objects are, let's say this one's at rest even. Okay, so there's a person running towards this one. Okay, and it's going to hit this object here. And let's say that these two objects have different masses. Let's say that this is 1 kilogram here. Let's say that this is 2 kilograms here. Okay, and this is going to be running with a speed of 10 meters per second, and they're going to collide, and you want to find out what is the final speed once they collide. So once they move off together, what's the final speed? So here you go. So this is going to be your after. So I'm going to call this before right here. So this is my before, and this is my after here. And one of the cool things about momentum is that it's conserved. So I know the momentum of this whole system is going to be conserved. So if I looked at the whole system, okay, and I'm going to call this my system here. So I'm going to put a dotted a boundary around this just to show that that's my system here. So the whole momentum of this system is going to be conserved before and after. Okay, in other words, the momentum of this whole system, whatever I calculate it, is going to be the same as this one in the end. So if I say, okay, the P initial of this whole system, which is the momentum, is the mass times velocity of the first one plus mass times velocity of the second one. Well, the second one's not moving, right? So the total momentum of this system is just going to be 10 times 1, right? So if I wrote that, let me move this up just a little bit here. If I wrote that up here, I would say, okay, well, my initial momentum here, letter P is momentum, is going to be 1 kilogram times 10, or it's going to be 10 kilograms meters per second. So for the whole system here, that's the momentum. Now, at the end, I can apply it again. I know, okay, well, here's 1 kilogram, here's 2 kilograms. What's the final speed going to be that they move off with? Well, I know my P final is simply going to be the sum of the masses. Let me move this up once again here. It's going to be the sum of the masses times the final speed, because now they're moving off together as one unit. So it's going to be M1 plus M2 times the V final. And so if I did that, I would say, okay, well, I got the mass is 3. I don't know what V final is, but aha, I do know this. I know that the momentum before has to equal the momentum after. They have to equal each other. So I can set them equal. So I can say, okay, that P final right there, I can say, okay, so P final is going to be 3 times V final, but I know that that whole thing has to still equal 10 inside the system. So 10. So V final is going to be 10 over 3, or it's going to be 3.33 meters per second. So it's going to move off much slower at that final speed than the first one was running. Okay, because let's say this is football, this is a little guy coming to tackle a big guy. They're going to move off, but definitely much slower, 3.33 meters per second, and that's going to be going to the right, because this is a vector, it's velocity.